Hello everyone, I Puneet Upadhyay, HOD of Mechanical Department, handling the subject Mechatronics. Before beginning the next session, let us brief out the last session what all we have studied. So in last session, we have studied regarding what is actuation system. So what is this actuation system? It is nothing but the element which is responsible directly or indirectly for imparting. Next, the different types of the solid state switches. So here there are basically 5 types of switches such as the diodes, the bipolar transistors, the thyristor, the triac and the Mosfet. Next, the simple actuation systems. As you know, the actuation is nothing but the movement from one part to the other part, okay, with by using the simple technique. So here what happens, the actuator is a device that makes something move or operate. It receives the some source of energy. Energy may be in form of electrical, or it may be in pneumatic, or it may be in the hydraulic form. Next one, the relays. So what are these relays? Relays are nothing but the electrical operated switches in which the changing current in one electric switch, the current is on or off in another circuit. Next one, the diodes. So what are these diodes? Diodes are nothing but which makes the flow of current in only one direction. It may be in the forward direction or it may be in the backward directions. Next comes the Mosfet. What is Mosfet? It prevents the flow of a current, okay, through the gate. It acts as the control part. Next comes the solenoid. So what is this? The solenoids? Solenoids are nothing but the it consists of the coil in which the coil is energized. So when the coil is energized, the EMF is induced. Okay, then when the EMF is induced, it makes the core to move to increase the flux, which provides the linkages by closing the air gap between the cores. Then last one are the important questions which are discussed regarding the examination point of view. So now next begin the next session, that is the session. So session 8 is a continuation of the session 7. So what are we going to study in this session 8? So in this session 8, we are going to study what is the AC motor, the DC motor, the working of the AC motor, the working of the DC motor, and important questions for the examination. So what is this AC motor? AC motor is an electrical motor driven by an alternating current. Okay, the AC motor commonly consists of two basic parts: an outside stator, which is having the coil supplied with an alternating current to produce a rotating magnetic field, and an inside rotor attached to the output shaft, producing the second rotating magnetic field. So this is regarding the AC motors. There are basically two types of AC motors. First one is induction motor and second one is the synchronous motor. Next comes the DC motor. So what is this DC motor? The DC stands for the direct current. DC motor is any class of a rotary electrical motor that converts direct current, electrical energy into the mechanical energy. So this is regarding the DC motor. The types of DC motor. So basically there are 6 types of a DC motor. There are first one the shunt motor, the separately excited motor, the series motor, the compound motor, the permanent magnet DC, PMDC, and the servo motor. Next, the working of an AC motor. So here the figure shows, okay, there is the first half period and the second half the period. So here in an AC motor, there is a ring of an electromagnets arranged around the outside, making up the stator, okay, which are designed to produce a rotating magnetic field. So you can see here, so this is the ring. So this is north pole and the south pole. So this ring will be rotating. So you can see the directions of the rotations. Okay, inside the stator, okay, there are the solid metal axle, the loop of a wire coil within the squirrel cage made of the metal bars, and interconnections or some other are freely rotating metal parts that can conduct electricity. Okay, so here the winding will in the form of the squirrel cage with made of a metal bars, okay, which are interconnected. So or sometimes it may be freely rotating metal part. So unlike in a DC motor, where your speed power to an inner rotor, okay, in an AC motor you send power to the outer coil, then that makes up the stator. So in DC motor what happens, okay, the power is sent to the inner rotor, whereas in AC motor you can send the power to the outer coil that makes up the stator. And next, the coils are energized in a pairs in a sequence, producing the magnetic field that rotates around the outside the motor. Okay, here when the first half you can see the directions, okay, that is from the north pole to the south pole, you can see the direction that is in the orange line. So in the second half you can see the directions, that is a reverse directions, while the north pole switches from left side to the right side, and the direction also changes from right direction to the left directions. So this is nothing but the working of an AC motor. Okay, this is explanation regarding the AC motor. Next comes the DC motor. So here the DC motor is explained with a symbol by the multipolar DC motor. Here you can see the figure which is related to the multipolar DC motor. So here when the terminals of a motor are connected to an external source of an DC supply, the field magnets are excited, developing alternative north and south poles. Here you can see the north pole and the south pole, which develops the field magnet. Okay, next one, the armature conductor carries current. The part of multipolar DC motor also conducts under north pole, which carries a current in one direction, while all the conductors on the south pole carry the current in the opposite directions. Okay, the armature conductors under the north pole carry currents into a plane of the paper, that is denoted by the X as shown in the figure. So here the current carrying in the north directions are represented by these X directions. Okay, whereas the current carrying in the south poles are represented by the dot that which shows in the figure. Since each armature conductor is carrying current and is placed in the magnetic field, a mechanical force acts on it. Okay, on applying the Fleming's left hand rule, it is clear that the force on each conductor is tending to rotate the armature in an anti-clockwise directions. So this is the anti-clockwise directions. So what is clockwise directions? Which moves opposite. So this is the clockwise. So here due to the Fleming's left hand rule, it moves in the anti-clockwise directions. So here what happens? All the force add together to produce a driving torque which sets to armature rotates. So here what happens? The north pole and the south pole, since they are moving in the anti-clockwise directions, here the both forces are mixed together. Okay, which produces the driving torque. When the conductor moves from one side of the brush to the other, the current is that the conductor is reversed. At the same time, it comes under the influence of the next pole, which is opposite polarity. Consequently, the direction of the force of a conductor remains the same. So what happens here? When the conductor moves from one side of a brush to the other, there the conductor is reversed. At the same time, it comes under the influence of the next pole, which is opposite to the polarity. So here what happens? The constant, okay, the direction of the conductor remains the constant. So this is explanation regarding the working of the DC motor. Next is the important questions for the examinations. So basically 4 important questions that are mainly asked for the examinations. Thank you.